Alrighty, lads and ladies, welcome back to the kind of final parting message here for college algebra. In class today, we did not have time to talk about how to solve systems of inequalities. We talked about how to solve systems of equations, linear equations specifically, but we didn't talk about nonlinear systems, and we haven't talked about systems of inequalities. So today, right now, at least my intent is to go through and show you how to solve those so you're ready for them on the final. You can complete those last few homeworks, all of that good stuff. So I'm going to go ahead and turn on the screen share. Just like class, only nobody's here. We can get moving. All right. So this is MAC1105, section 007, and it's a kind of extra lecture. The 22nd of April, 2021, of course. So today, now, we're going to talk about solving nonlinear systems of equations. And solving systems of inequalities. So I'm going to talk about the nonlinear systems first because this is fairly straightforward stuff. You solve them the same way you solve linear systems, except you usually have to use substitution. You, for the most part, cannot eliminate when it comes to nonlinear systems of equations. It's not always true. There are some nonlinear systems of equations you can get away with elimination, but for the most part, you will need to use substitution. So I'm just going to jump in with an example here. We're going to solve the nonlinear system, x squared plus y squared equals 4, and x minus, how about 3y equals 0. So this is indeed a system of equations, but it's not linear because the first equation here is not linear. Right, you've got an x squared. That on its own would make this nonlinear, but you also have a y squared. It is the case, although you may or may not know this, that the first equation is the equation of a circle centered at the origin of radius 2. The second guy, of course, is a line. So I could draw this system for you, but since I don't necessarily expect you to do that, because I don't expect you to necessarily know what this is, I'm just going to jump in here. So we're going to solve this using substitution. We use substitution. Because the system isn't linear. So anytime you have a nonlinear system of equations, again, we're going to assume that you need to use substitution. I'm going to solve equation 2 and solve the second equation, EQN for equation for x, because that's easier. So here what that's going to look like, I'm starting with the second equation, which is x minus 3y equals 0. And I can just add the 3y to both sides, and that will give me x equals 3y. And then, just like the substitution example we did in class earlier, you substitute this in everywhere you have an x here. So now we sub x equals 3y in the first equation. You see, it really is the same thing that we did to use to solve a linear system by substitution. So my first equation is x squared plus y squared equals 4. And if I plug 3y in for x, that means this piece is going to become 3y all squared. And then we still have the plus y squared and the equals 4. And now I clean this up and solve for y. So this is the same as saying 9y squared plus y squared equals 4, and 9y squared plus 1y squared, that's 10y squared. So we get 10y squared equals 4. Now I can divide both sides by 10, and I get y squared equals 4 over 10. And I can take square roots. So y is 1 of plus or minus the square root of 4 over 10. And that can be cleaned up. The square root of 10 is not nice, but the square root of 4 is nice. So this is plus or minus 2 over the square root of 10. Just taking the square root of the top and bottom separately. So we know that y is equal to negative 2 over root 10, or y is equal to positive 2 over root 10. And it's going to turn out to be the case, right? Just like the earlier substitution problems, we're going to plug each of these into the other equation to get our x value, that we get two solutions. So the line here, x minus 3y equals 0, intersects this circle twice. Let's go ahead and finish it up. So now this stuff is kind of our step 3, right? Solving for that equation. But now our step 4 is to sub these two values, or this plus or minus 2 over the square root of 10, into the other equation, the second equation, and solve for x. I'll do one at a time. We have x minus 3y equals 0. So when I plug 2 over the square root of 10 in for y, I'll get x minus 3 times 2 over the square root of 10 equals 0. So again, here I'm plugging in y equals 2 over root 10, the positive value. This is the same as saying x minus 6 over the square root of 10 is equal to 0. And now I can add that over to the other side. So x is equal to 6 over the square root of 10. So when y is 2 over root 10, x is 6 over root 10. So one solution is 6 over the square root of 10, comma 2 over the square root of 10. And that came from plugging in this y value. On the other hand, if I plug the negative y value in, y equals negative 2 over the square root of 10, then x minus 3y equals 0 is going to become x minus 3 times negative 2 over the square root of 10 equals 0. And this is the same as x plus 6 over root 10 equals 0. Because the two negatives here, when you multiply negative 3 times negative 2, you get positive 6. And now I'll subtract this term over, and I get x equals negative 6 over the square root of 10. So the second solution is negative 2 over the square root of 10, comma, negative 6 over the square root of 10. And this is it. So nonlinear systems, if we can solve them, are fairly straightforward. It all comes down to how difficult the algebra steps themselves are. And the stuff that you guys will see is going to be very, very simple. I don't think you will have a hard time with them. Just remember that with a nonlinear system, you need to solve using substitution. With a linear system, you want to use elimination. It's faster, it's the smarter way to do it. But with a nonlinear system, you want to use substitution, just like we did here. The other thing we didn't get to talk about today was systems of inequalities. And so it kind of has a warm-up or a primer. I want to talk about linear inequalities. We won't make you solve nonlinear systems of inequalities. At least I don't believe we make you do those. We have done in the past. It's the same principle. But let's start with linear inequalities at least. So if I have something like 2x minus y equals 1, you know that this is a line. Right? You can put this into y equals mx plus b. The slope of the line here is 2. The y-intercept is -1. But if I change this to a greater than or equal to, what does that do? Well, we kind of start by thinking of the line. So I would begin by putting this into the closest thing I could to slope-intercept form. I'm going to think about this the same way I would think about a linear equation. So I can subtract the 2x over, and I get negative y is greater than or equal to 1 minus 2x. And then I can divide both sides by -1. And remember, when you multiply or divide both sides of an inequality by a negative number, the inequality symbol flips over. So when I get rid of the negative over here, this is going to become y is less than or equal to -1 plus 2x. So just like with an equation, the only difference is this inequality flips over because I divided by a negative. So that's a line with y-intercept -1, slope 2. It's going to look like this. Now we've got y is less than or equal to this thing. So the less than or equal to tells me I want everything below or on that line. So to kind of graph this inequality, I would shade everything beneath this line. All of the ordered pairs where y is less than -1 plus 2x. And that would be it. Really, the only way we can neatly write down the solutions for these is by graphing and shading. So this really would be the